Well, welcome everybody. Glad you can make it here to intro to blockchain 2020. And if you can please just put a hello in the chat window there, that'd be great. My name is Russ Fustino. I'm a developer advocate for Algorand, and we got a really great session on tap for you. So let me go ahead and go forward to a couple of slides here. So I'd like to also thank our great sponsors for this event. Without them, this would not be possible. So a round of applause, yay, for all of our sponsors. So, hey, Tina, how are you? Nice you can join. We're going to start out with a little bit of a poll question here. I know you had another poll question before on for the conference in terms of what language, but we're going to do it just for this room. So let's say I'm going to, if you can go ahead and go out to this site, either go to slido.com and enter that number in, or if you have a, a scanner on your phone, you can scan the QR code and go right to the poll. And let's give you a minute or so to do that. So the first question that's on the screen is number one, are you a developer? Yes or no? You got one so far. I got three questions here lined up for you. Oh, good, Tina. Glad you can make it. So let me know if you're having problems getting to that site or not. I only see one vote so far. I'm trying to figure out, what your experience level is with developing and also with blockchain is what we're attempting to. Okay, loading slow, but getting there. Thanks, Wayne. Appreciate that comment. I love this IDE here for doing presentations with having the chat window right there, and you've got reception, the stage, networking, and expo, and all this stuff. This is really great for an online event. Really, hats off to the Code PaLOusa team, and Chad did a fantastic job on getting this going. So I'm going to go ahead and put that response in as well. And or if you want, I think there's only a few of us here. If it's easier for you just to put that in the chat window, are you a developer? Yes or no? That would be also just as effective here. How does that sound? Maybe that's an easier way to do it today. All right, we're going to go to the next question here and do this one now. So what languages do you use? There's a multiple choice on this, so if you use more than one, you can go ahead and select that. All right. Oh, we'll get some voting going on here. Good. JavaScript. All right. All right. Very good. And the final poll, this is how experienced are you with blockchain? Are you brand new, year or less, more than a year? Okay, looks like we got brand new here in this room. All right, that's great. Thanks for your participation in that. And let's go ahead and get back over here to the deck. And I'll actually close that out there. All right, very good. So Algorand, borderless economy, borderless opportunity. We're defining the standard in blockchain technology. And I really do firmly believe that. Get the goods. If you want to take a picture of this, you can. There's a bit.ly address for the PowerPoint, today's PowerPoint. I always like to put this up front. So that's a 3 and a small j, a 2, a small h, a capital W, a, and a small j for the bit.ly address. And I think I'll actually, I'll just go ahead and copy that into the chat window as well. Make it a little bit easier here. And I'll put that over here. So maybe it's easier to follow along. All righty, we'll continue on then and get into our session here. So, centralized data issues. This is in the news, right? About a month or so ago, the White House had changed their mind in terms of where they want the COVID-19 data to go to. They want to use a different federal database. So instead of going to the CDC, they want to go to the Department of Health. And then there were concerns about it could disrupt public access to the data. And this is common things, right? With centralized data issues is, why not to have this globally available to multiple, branches simultaneously, is the point here. Also, you're hearing a lot about breaches, right, into almost daily on data centers being hacked, right, and going into, and privacy of information is gone. And so this is a definite problem that has been creeping up and getting worse and worse over the years. And then voting by mail, that's a very, very big topic right now. And there are some that say, hey, this is a very dangerous thing. Others say it's not dangerous, but that's not the point. The point here is how about having a way to have a voting system that is not necessarily in person, and get into a good way to do voting. So I actually have a little solution I'll show you later on that maybe could be the start of something like that going forward. But I will leave you hanging on the edge of your seats on how we solve that one, right? And then, really, blockchain is not the future, it's the present. Blockchain's usage is becoming ubiquitous across multiple sections of the economy. The medical field. I went to the doctor, a few months ago, and as a new doctor. So you got to go through a half hour's worth of filling out forms and paperwork and your history and all that. And every time you see a new doctor, the same thing. Wouldn't it be nice to have that globally accessible? And not only that, some folks are incapable or maybe incapacitated, right, where they can't fill out something like that if they're seeing a new doctor. And so these are all taken actually from the China blockchain report for 19 and 20. And, charities was another thing they identified in there, where Red Cross had a misuse of funds about 10 years ago with one of the earthquakes that they were helping to facilitate. So it would be really nice to have an immutable ledger. And really, blockchain's primary purpose is, to maintain the integrity of data. It's basically you could think of it as a read-only, write-once ledger, or mini database, right? That is available to all. It's actually a distributed database, so it's on, anybody that wants it can have it by running a node. You have your own copy of that particular data store. So that's kind of where we're going, and also in terms of it being very easily detectable for being tamper-proof. I had an attendee about a month ago. We did a session for the cybersecurity expert that came to my session. It was for the Women Who Code. And she said, the way she likes to think about blockchain is, how there's two-factor authentication. Well, blockchain is like two-factor authentication times the number of blocks in the chain. And so when you think about that, that's pretty secure in terms of how, the data is. And so a lot of these industries are really coming around to this, and it's really solving a lot of problems in the telecom industry, the food industry, automotive, anything that's got a supplier chain type scenario where you have multiple sign-offs along the way. Those are also great solution ideas for solutions in those areas. So also with developers, right? Most here are developers here as well. And I think, I did a quick survey before the meeting here today on blockchain jobs, right, at CareerBuilder, Monster, and Dice, and there's thousands of them. And there's a good number of developers. Kind of hard to track down, but I did find a few stats on that for late 2018. It was over 100,000 developers that are engaging in this particular space. And I always know it's a very tough thing to kind of decide on what your next technology is going to be as a developer that you're going to learn. I've been doing developer work my entire career. I've been doing developer advocate work over the last 20 years. Used to work for Microsoft, and this is always a big question. You know, what's the next big thing? And you know, the biggest fear developers I found have is, you know, engaging in a technology that becomes a white elephant. You know, if you spent a year ramping up on a particular technology and then it disappears, it's like a year wasted on your learning curve for other technologies, and then you got to retool again real quick to get another job. So I'm here to tell you, blockchain is here to stay, and this is just going to be growing. And I think this is a great idea, right, to start engaging here. So we're going to cover over the course of this particular session is the blockchain basics, and then we'll talk about, you know, Algorand itself. We're going to talk about layer one, which is on the Algorand blockchain, which is basically, for those who aren't familiar with layer one or layer two, layer one is right on the blockchain itself. A layer two type solution would be like maybe authentication app or something that would sit off the blockchain, but then you know, allow people to access that particular application, for example, might be an example of that. Algorand Foundation rewards program. So there's actually incentives here to start developing. And then a lot of great developer tools. Got some great code demos showing off the code SDKs that we have. And so it should be a fun hour. So let's get started with blockchain basics. And feel free to go ahead and type in, you know, questions in chat. You can see it very easily here. And so let's start out with this. You know, basically, like I started talking about, it's a section of blocks, right? One linked to each other with a one-way hashing algorithm. And way you can think of a block is simply it's a record, and each record has an associated record, which is transactions. It could be one-to-many relationship between the block and the number of transactions that are being cast when that block is written to the chain. Some of you may have heard of other blockchains like Ethereum or perhaps Bitcoin. You know, those are older blockchains. You know, Bitcoin's been around about 10 years. There's got to be a better way, right? Because like any technology, things change, and things, you know, that are 10 years old typically have a better way of doing it. You know, what about forks you may have heard, or proof of work? We don't do either of those. And by not doing either of those, you really speed up the ability to create blocks on the blockchain. Right now, for example, with Bitcoin, it's about 10 to 15 minutes, and it also consumes a ton of power, right? They have this mining you may have heard about that has very expensive equipment, solving very, very difficult math problems, and it's not green at all. And that's how they determine the winner, who votes on and writes the block to the chain. Concept is great. Implementation, you know, we've definitely improved on that. And so what we use here is something called the Byzantine agreement. And for those who aren't familiar with this, is back to the empire, where you had several generals that need to communicate or to determine whether they need to attack or not, you know, against you know, sultanate here. And so, you know, a lot of things can impede the message process and message carrying process. One might be a storm, one might be getting corrupted, maybe one has an injury and, you know, and can't you know, walk over to the next stop to communicate. So these are all problems, right? And if you don't have a consensus among everybody here, what you're going to find is failure, right? And if you go to start doing the attack here, you don't have a consensus, some troops may not have enough food or supplies or artillery, and your mission's going to fail. So that's the whole idea behind the Byzantine problem. So basically, Silvio Macaulay is our founder. He's also a Turing Award winner, really, really smart man, nice guy too. He figured it out. You really don't need everyone to participate, because what you're seeing here are scalability issues, right? As soon as you scale beyond 20 people that you're trying to get a consensus on, it becomes very, very expensive. You know, your costs get quadrupled, you know, and it can go, you know, skyrocketing in terms of, you know, the expense that's involved in kind of to come to a consensus. So he figured it out. What you don't need everyone to participate. What you need is a representative sample, and that's really the verifiable random function that we have, and it's really just simple statistics. This is how it works. You basically have a small committee, you know, randomly selected from all sets of users, and then the committee agrees to a block of transactions. Every member verifies transactions and digitally signs it, and the block is added to the chain. And, you know, rinse and repeat. Do it again. Next one. And these are done every 5 seconds. So you have some pretty fast capabilities. There's a really nice video. I'm not going to show it here, but it's in the deck. You have a link to it on Algorand's core protocol. And this brings us to this slide here. So on this here, basically, what we have is public and permissionless. Now, when I first started doing blockchain, I was, well, what kind of solutions can I build here? And if you look at this, really what a public blockchain is, it's a permissionless blockchain. On the other hand, a private blockchain is a permissioned blockchain. So when we talk about public blockchains, what most people are really talking about is a public open blockchain. It's a blockchain where anyone can write data to the blockchain, and anyone else can come and read that data. Public blockchain platforms like Bitcoin, Ethereum, and Litecoin, and now Algorand are what we also refer to as permissionless blockchain platforms, meaning they really strive by design to increase and protect the user's anonymity. But basically, you can always use these public platforms to build a permission solution. You just need to be aware that it's upon you, your architects, your developers, to create that permissioning model. And that all starts with some kind of identity management system. So in Algorand, we have a few different ways to do this, right? So we have a note field that's freeform, so any layer 2 app can build anything permission that they want, and then Algorand will not enforce any permission rules, though it has to be done like in a layer 2 app, like I mentioned. We also have other features like atomic transfers and smart contracts I'm going to be talking about to help facilitate some of those type of scenarios. So really, if you take a look at these types of apps, you look in the upper right corner, you've got the public and open. These are ones that, without any, fudging, these are completely open, right? You got currencies, betting, video games. These are all examples in that area. If you go to the upper left with public and closed, yeah, you want voting to be public, but perhaps you want the voting records to be, closed until maybe the polls are complete or something like that. And whistleblowers, for example, maybe you don't want those publicly exposed. And then you get to the bottom right, we got private and open. These are like really great for supply chain where you need some kind of control and sign off along the way. Good for government financial records, corporate earnings statements. And then you get down to the private and closed in the bottom left corner, which is basically construction, national defense, and law enforcement, military, tax workers. So those private blockchains that have those are on layer 1, where you have the authentication and everything there done. And that's really the biggest difference to kind of understand. So that is kind of a quick, summary of the different types of blockchain apps. So out of this comes our consensus protocol. It's called the Pure Proof of Stake consensus. It's public and permissionless, like we talked about. All users can participate in the consensus. Blocks are confirmed by voting. Every token carries the same voting power. No need to delegate or bond. Now, you may have heard or might hear at some point something called delegated proof of stake or bonded proof of stake. It's basically different in that the delegated proof of stake, delegates are known ahead of time to do the voting. The problem with that is they're subject to denial of service attacks because they are, in fact, known ahead of time. And bonded proof of stake is where you put up an amount of money and say, okay, I'm going to behave, but if I misbehave, the bond goes away. But once again, they are known ahead of time, and the stakes are different, right? If I put up $1 million bond, but I stand to gain $1 trillion by misbehaving, it's all relative, So really, with the pure proof of stake consensus, it's minimal compute power is required as well. You can run a node on a Raspberry Pi. That's how efficient it is. So that's kind of like where we're at in terms of the consensus. I'm going to take a look here at our question queue, see if we got any questions. Feel free to go ahead and, pop in questions as we go. And so what I will do here is then continue and oh man, how did that happen? I lost my window. Let's see here. hold on a second. Just give me 1 minute here. All right, here we go. Okay, I'm back. This is the page I lost, which I just definitely want to keep track of here. Okay. All right, back to our regularly scheduled program. Let's go ahead and continue with that. Sorry about that. Now let's continue on with why Algorand. So we do have that per proof of stake consensus we talked about, but it's all a very efficient blockchain. It scales to billions of users. Enterprise speed at over 1,000 transactions per second. And we are working on major enhancements on that to get even faster, much faster. But that's not bad right out of the gate. And also, block times get created in under 5 seconds. So think about this: with a blockchain like Ethereum, or with like with some of the older ones like Bitcoin, it takes 15 minutes. It's not really conducive for point of sale type solutions. Whereas now you can actually see this being part of a point of sale solution with speeds like that. Also, you have instant finality. There are no soft forks, and other blockchains that create forks. Many times you'll have orphaned forks that never see the daylight. So that's a waste of energy, a waste of power, and a waste of the blockchain. So very cost effective too. It's less than 0.001 cent of USD cost per transaction. So now you're looking at, making this really available to all points of the globe, including areas that do not have great, easy access to financial institutions. There's over 2 billion people that fall into that category on this planet. So this is really a good thing that's happening here. We're going to be able to benefit a lot of people and help a lot of people on this planet in the way of doing finances. And let me tell you, this is through 1 year worth of blockchain usage. We came out on mainnet a year ago, just a little over a year ago. And look at all these companies and solutions that are being built in the way of technical products, financial products, and really an ecosystem of applications, or like asset block, for example. You can parse out like a hotel that might be owned into multiple owners by slicing up the assets accordingly with the algos, for example. Algos are native currency on the blockchain. Or you can create your own asset. You can create your own coin. And that's called an Algorand standard asset. We're going to talk more about that. That's exactly what Asset Block is doing. And then you get other ones like World Chess. They're on our blockchain. KU Coin, BitMax, FTX, Binance. You've got partnerships and Cloudflare, and PureStake is another one that has an API service that you can call from your application, not even have to run your own node. They have a farm of nodes running, and they have an API to access their services. So that's really great for something like, say, a mobile application where you don't have local host available necessarily to you. Sure, you can put the IP address in, and also you can do, you can have a stand-up instance if you wanted, to access that programmatically, but not everybody's got those resources. And so PureStake provides a nice alternative there. What we're looking at by the end of the year is tracking 10 plus million users on this chain, estimating 1 million transactions per day by the end of the year. And these numbers are just mind-boggling. Again, this is just a year's worth of growth. Now, now you got over 300, close to 400 companies leveraging the platform. You got global exchanges. We are one of 2 blockchains with the top stable coins, USDC and USDT on there. For those unfamiliar with stable coins, one of the problems with crypto's currency is is the fact that it's very volatile, and it's very difficult to kind of wage your finances. And when one day it's worth a lot, next day it's not worth much. Well, the stable coin is tied to USD, and still cryptocurrency, but it's tied to a financial institution. So it's much less volatile. So that's a really great solution. We have over 50 wallet providers, over 500 nodes, globally distributed, as well as some ambassador program I want to call your attention to. Any one of you can become an ambassador, help us run events, help create content. We now actually have over 400 ambassadors in 50 different countries. So a lot of great stuff going on there. Okay, very good. Oh, so now I hear myself. That was a bad thing to click. How do I turn that off? Oh, good. Um, um, oh boy. Rebecca, I am hearing myself talk in my ear because I clicked on a button to hear it. And I got, I'm going to come back in. I'm going to leave him come back in. Be right back. Testing. All right, that's better. Rebecca, can you hear me okay? All right, Wayne, yes, good. Thank you. All right, we're back on track again. Sorry about that. So let me go ahead and make sure I've got this. I got my screen still shared. I think you can see that. And let me go ahead and continue on to the next one. So let's get down to some nitty gritty here in layer one features. We're going to talk about accounts, Rekeying, Algorand standard assets, atomic transactions, and Algorand smart contracts. So basically, there's three type of accounts where you have a standard account. You can equate that to like an individual, a multi-signature account where you have a group of folks and you have a threshold of, say you have 5 people, maybe if any 2 agree to spend for a transaction, then that gets signed. And that's what you see, those little keys there are like signing keys, right? To be able to spend, they call them spending keys is another way to think of them. And then also you've got a logic account, which is a smart contract. So that returns true or false. And if it returns true, go ahead and sign it. And if it returns false, it doesn't spend the money. So that's kind of at a high level, the type of accounts. And then we actually just released this feature yesterday, rekeying accounts. So what you have is a public address associated with a particular account, but then you traditionally have had like a signing key that's one-to-one associated with that particular account. Well, what happens if you want to change your signing key? Then you had to create another public address, and then you lose the first one. So this was a problem. So what we did was you can keep the same public address, but then change your type of key. If you have, you can even like swap out a different smart contract if you wanted to, right? To go to that. So very big feature. Again, we announced that and a few other really big items yesterday in our big protocol upgrade. Algorand standard assets we've had for about 9 months now. This was really a big feature to the blockchain. You can create your own native token, basically, like an algo or any kind of cryptocurrency. You can, create. I can create Rust coin, if I want to out there. It only takes minutes to create it. Requires no on-chain code to do this, unlike other blockchains. You can administer several different areas, to mint and burn the units, to freeze accounts, to revoke assets, and delegate. So these are all things that can be done. There's also asset spam protection built right in. Accounts have to opt in, to accept an ASA. And I'll show a little demo on this later on, where there is a visual IDE to create this. So I'm going to show you both. I'm going to show you how to create it programmatically assets, and I'm also going to show you this tool from Algo.io. It's a third-party control, another community product. Our community products and solutions are thriving. Atomic transfers. All right, so a traditional thing, you go to a grocery store, it's basically comprised of two pieces, right? You pay the money to the cashier, and the cashier provides the the food to you, right? And then you walk out the door. Without either one of those happening, it's not a done deal, right? It reverts back. For those that are familiar with SQL transactions, it's very similar to a SQL transaction where you have many different pieces to it, different tasks. And if any one of those fails, it rolls back to like nothing has happened. It's the same kind of mindset here with atomic transfers. So you can do up to 16 of these all at once, almost succeed, or they fail. And this guarantees exchange of goods, because that's always a problem, right? If you go to, buy tickets, off of, a ticket agency site that you never really heard of, or maybe it's on Craigslist or something. I know people have gotten burned on that. And so if you don't have someone that's a trusted authority, this type of an approach with atomic transfer solves that. And then we get into smart contracts. So our contracts are written in a programming language called TEAL, which stands for Transaction Execution Approval Language. There is also a Python-enabled compiler called PyTeal, so you can write these in Python. Two types of smart contracts. One is stateless, and this is used to approve spending transactions. And brand new one that just got introduced yesterday is stateful smart contract. So this provides on-chain, global, and local storage. So the global would be available to, globally, as the name implies. Local storage might be like on a per user basis, for example. Both of these with other Algorand technologies. You can combine it with atomic transfers or Algorand assets, for example. Maybe you got to check to see if the person has any of those assets in order for a smart contract that's working with those to approve it, right? So you have to, kind of work both of those technologies to really make it legit, and make it foolproof. And then also you can combine stateless and stateful together, of course. So the way it actually works here, it's a stack-based language, very assembler-like. There's about 90 different opcodes. It's assembler-like because it's lean and mean. This again is on layer 1, so you really want that to be very efficient. You don't want it like a huge VM sitting on each one of the nodes, because that's very, very consuming of power. You have access to ASA and algo balances. You can read all transactions in a group. You got stateful and stateless calls that can be made, and then the PyTeal library, like we talked about. So basically, you push onto the stack and you pop it off. And the way it works here, say you got all these listed transactions here on the right. So I'm interested in, taking this first transaction for the commander. So on the left is the TEAL program. And then the very next thing I want to do is say, okay, I want to take an address to close that with, right? And so then the next step is going to be, well, I'm going to pop those two off and replace it a 1 or 0, saying, okay, is that true or not? If it's true, I continue. And really the end result of this, whether this whole script is true or false, if it's true, then you're going to be able to sign off. If it's not, it won't sign. So that's pretty much it in a nutshell. And this is what the Python library looks like, where you can see you can do an import. You got to define your method there for bank for account with the receiver as a parameter. You've got all of these, this code that you can put in to, for the payment, for the receiver, for the transaction, and down below you call the bank account for the passing in that particular address. And then what it returns is the actual Python code right down below on the right. So very nice tool. A lot of folks really love that. And there's another great video here on our YouTube channel for Algorand on Teal. One of our engineers did this. It's fantastic. Algorand stateless smart contract. So this replaces signing of transactions, or not replaces, it's another way to sign transactions. There's two modes of use. One is a logic account. In other words, transactions sent from this account will be verified by the predefined logic. So simply whether it returns true or false, then it's going to execute or not. This is great for escrow style accounts, split payments, hash time lock contracts as well. And then the other type is a logic signature, which is similar, but there's also, in addition to the program passing or failing or being true or false, it has to be verified by predefined, like a delegated authority. So there would be an additional, basically, signature check and that type of thing. That's good for like recurring payments. And this is for smart contracts. Then this is kind of the way it works. You have a smart contract, and there's something called application call transactions, and those trigger the smart contract. And the smart contract then can store the global state, and then, for example, or store it on like a per user basis, for example, on the local state. So it's really nice to remember things right in the blockchain without having to have a third party software or another place to store this, because really we want all this data to be decentralized. And then I mentioned you can combine a lot of these features. So this is a good example of combining some of those. Here we got like a voting commission account. For voting, like we talked about up front, one of the pain points, right, that we're all experiencing right now here in this country. You got to, like, maybe you can have a voting commission account, and they would issue a spend voting token. And these would be grouped atomically. So basically the candidate would have to vote. And if they voted already, it would not satisfy that grouped atomically transaction. And so, for example, all of the tokens that you create have all the native features of algos, or native currency. All those, protects you against double spending and all that kind of stuff. And then, you have the voting smart contract as part of that. And if everything goes good, then I'll go ahead and increment a candidate total vote, which would be stored, guess where? In a global state. So it's accessible to all. And then here's another one here for crowdfunding scenario, where you have an escrow account, you have a stateless smart contract, you get the payment from the escrow user. If you don't raise enough funds, then everybody gets their money back. If you do raise enough funds, then you got a smart contract there that's managing that whole thing, and you're good to go with that particular approach. We actually have those two solutions written up on our developer.algorand site, so you can have all the source code and everything available to those scenarios. Another thing, a great resource I want to make you all aware of is the Algorand Foundation. The Algorand Foundation is a separate business entity. They are the money side of the house. So where I work for is Algorand Inc., and we are the technology side of the house. There are several reward programs. First and foremost, there's developer reward programs where you can, we had our C# SDK was written with that. We had a fellow wanted to write a C# SDK. I actually got a demo on that I'm going to show you, because I know it's predominantly a C# card according to the statistics I saw earlier on the make here. So I'll show you that as a result. I got a Xamarin app I created on that. And then for iOS and Android, then you got the Algorand Developer Ambassador Rewards Program. So you can become an ambassador as well and get additional rewards. In short, that's called DevAms. And grant programs. There's another company that's interested in upgrading our C# SDK, for example, through a grant program to V2 and a lot of the protocol updates that we released yesterday. Ambassador rewards program as well. Becoming an ambassador, you can get some money for just helping out in the community. So some good things there to call your attention to. Let's get to the best part of the session here, developer tools, right? So we got a lot of SDKs that are supported from Algorand, JavaScript, Python, Java, Golang. Python is just amazing how it is gaining in popularity. I was out at the Stack Overflow survey the other day, and it's just like, it's skyrocketing. It's going right up. And we also have command line tools. And we got, like I said, the C# SDK also is one of our community supplied SDKs that we have, which is very, very solid. I really was very pleased with that, and contributed a few pull requests on that to the GitHub repository. Also, we got the CLI tools, command line tools, so you can work with the node from the command line. Excuse me. 1 second. Good old entertainer secret really helps out in a pinch like that. All right, Sandbox is a really quick way to get set up and started going. It basically creates a Docker instance. You can actually run that on Windows, Linux, and Mac. All of those will run because it's a Docker instance. I use that all the time. Indexer V2, a huge announcement came out about a month ago. Traditionally you would be searching for maybe in chunks of 1,000 blocks at a time on a blockchain. It gets to be very expensive and time consuming. Instead, what we've done is created a service that you can spin up yourself to scan the whole blockchain and basically create your own progress database that you can do queries off of. And I'll show you a demo on that as well here today. You got wallets. The Algorand mobile wallet also has been expanded recently to go look at testnet. It's one of our networks that we have. We have mainnet, testnet, betanet, and then also Algo Signer is a Chrome plugin coming soon for signing transactions, very similar to MetaMask that's out there for Ethereum. And then a lot of great amount of community supplied products. In fact, my current task is to update our community page. It's changed so drastically, so quick. There's so many new tools out there. You got explorers, you got API services, additional wallets, SDKs, Teal editors, Algorand Studio editor. This is really good stuff. And we also have a great newsletter. Take a snapshot of this or whatever. Sign up for our newsletter to keep aware of everything going on. It's out in our developer.algorand site. There's a little link at the very bottom right corner. If you scroll down to the footer of the page for the newsletter, you can find it there. This was the one that was sent out today. You can see we've got stateful smart contacts in there, rekeying. I didn't talk about fast catch up, but if you create your own node, typically it'll take 2 days to catch up. And this is not unfamiliar to really any blockchain, but we incorporated technology where you can create a node and get caught up within a matter of minutes, and it's just fantastic. So you are up and running right away. This should be a problem you used to have at hackathons. We go to a hackathon, they create a node, and it's like, oh, okay, the next day they can start working on it, and that's too late. The hackathon's over, So this was really a good thing. This is a diagram of our networks I alluded to. BetaNet is typically the one where we introduce things first. So this last protocol, an SDK change, it had BetaNet for a few weeks, and then yesterday we just rolled it out to testnet and mainnet simultaneously. Now, testnet and mainnet are mirror images of each other in terms of functionality. So the idea is you can use testnet to test anything you want, and it's going to work on mainnet because it's the same code base. And then also testnet has things like dispensers, as developers can pump algos into your you need to have like that transaction fee we talked about. You need to have some kind of algos in your account to do transactions. So those are all done. And then also we got something called private networks, which is not revolved around security. It's really more, I view it like more like a personal network. So it's good for a stable environment you can create. It's good, for example, if you're testing off of something, a BetaNet, which is volatile and could change. You can basically keep your own copy of it locally through a private network. You could also set one up for testnet and mainnet. All right, so let's talk about different types of nodes. So you can create and run your own node, and by node I mean you got to copy the database, right? Plain and simple. You can run a Mac, Ubuntu, other Linux distros. Example, Raspberry Pi, you can run a node. Again, used to take several hours to sync, but now with fast catch up, boom, you got it. There is a section on our started building here, the workspace setup and connect your node that goes into all these options. You have third-party vendors like PureSake that provides an API service, index and archive. Also, you can access the from SDKs on platforms that do not have nodes, like Windows, for example. And then you got a sandbox. And then I do know of Algorand Ambassador that's working on creating a community-based Windows node as well. Lots of stuff going on with our community. It's so good to feel this. I mean, it feels like the first days of Microsoft when I was there back in '97, and we didn't even know who our developer community was. And then we started running events. They came out of the woodwork, and oh, the rest is history, right? Then we built a developer community out of that. And same thing's happening here with Algorand. It's really amazing. The sandbox, it's Docker. It's not for production. Although you could run a snapshot of mainnet in it. However, as soon as you switch it to go back to testnet, everything gets wiped out. It's a temporary solution, basically, but it's really quick and really fast. And all of our all of our features on the site have code examples, and they're all preceded with the sandbox token and URL. So pretty much they run right out of the box now too. No sync time on that. And these are some of the commands you use to get started with that. And then V2 we talked about for indexer, again, accessible from all the SDKs. It runs off chain, it runs off of the blockchain. It's not tied directly to an Algo D process. Algo D is our one of our daemons, right? That is used to broadcast transactions and things like that. So basically, it just creates a nice database for you that's very queryable and easy. Developer.algorand.org. This is a site I spend most of my time in every day creating content for this. We've got a ton of tutorials, ton of solutions, ton of articles, and great documentation on the feature set as well as a very active forum. So I encourage you to take a look at that as well. And then start building, right? There is a section there to get you set up fairly quickly to do your workspace, connect to a node, do your first transaction, and newly added now build an application. In other words, a smart contract. So that is great. I went through that step by step a few weeks ago. Very, very good set of documentation, all three of those. Then you can see here's a sample where we have this example permission voting, smart for contract application, also a solution for the crowdfunding that I talked about. Articles, many of these are written out there. I've got quite a few. You can see my little face there. There's a good one here for getting started with Algorand. I go through all the resources, right, that you have. A lot of things I'm covering here in this session. And then you got great tutorials. Each tutorial, if you scan down, typically toward the bottom, there's a link for all the source code. And in the way of community resources, again, becoming an Algorand ambassador has lots of perks. You can contact Stephen there, Stephen at algorand.foundation, and visit our community.algorand.org site to get more information. And there's a few more community sites. There's a community landing page, a community blog, and if you'd like to post a blog there, just send it email to ecosystem@algorand.com, and a lot of community events as well. Yeah, here's the C# SDK. It's up at Riley G. He's got a .NET Algorand SDK and it is .NET Standard 2.0, so you can use it with Xamarin, which is great. And then time for some code demos. So let me go ahead and just make sure I'm not missing any questions in the queue here. All right, looking good there. So let me minimize this. And the first one I'm going to show you here is a JavaScript example, and it shows the core functionality, and I'll go through the code we're going to use here in a second. And so once this comes up, There we go. So here's our file. So here's a function to get the latest block that's on the blockchain. All the information comes back with that. And you can see the first round and last round for the transaction. They're usually 1,000 apart. This is our 2 account. We're going to send some money with this demo. We're going to send this amount here, the 739,000. Those are micro algos. Now what I'm going to do is generate an account to do this sending from. So I've generated the account. I'm going to get the account details. And in order to send money, I got to get money, right? So the very first thing I'm going to do here is go out to my, oh yeah, here it is. Bring it up over here so you can see it. Dispenser. And I'm going to go ahead and do this. And we're going to put in the amount. I'm going to do my crosswalks here. Yeah, it's pretty easy. Usually I got to squint and see everything. Okay. And we're going to dispense some funds to that. So now we'll come back over to our account. I'm going to recover the account mnemonic. I can get the account details. And what you can see now right here is the amount, right, that got transferred. So now we'll go ahead and submit a transaction from account A to account B. And there's the transaction ID. And I can actually say copy that, and I can get the transaction. This is the note field that has a structure defined to it that gets displayed here. And again, if I go back over to, say, one of these Algo Explorers, I'm on testnet here, so I can actually put in, that transaction, and it should go ahead and find that transaction out there that we just created. And there's the 739 amount that just got transferred, and the message pack that gets sent out. So some really good stuff there, and you can encode this, for example, and that would be done. So if you take a look at the code here, that did this. And I know many of you are C# developers, but I think you'll get the idea here. And actually we'll step through some C# code in a little bit. But the idea here is you got all these, instantiate the SDK, and you're going to pass in a token and a server, right? So the token we have up here, this is the token for the sandbox. It's running on localhost, and this is the port. These two always stay the same for sandbox. And then there's another daemon we have called KMD. We don't actually use this in the demo, but if you did like an online wallet or something like that, you can use KMD for that. Most wallets are done on devices nowadays, so that's really not that popular. And then we got the client established, right? And then we're going to just do an account information call. So that's going to go ahead and get the information. You see all the stuff come up that we just executed here. We've got the round number, we've got transactions, and then you can see in the code, here's the call to get the block status that we looked at. You get the status, and then you get the round, and you say, okay, give me the block information in that round, and it will go ahead and do that. Here's the one we used to generate the account, and this is where we got that. I don't know if you noticed or not, but there was a secret key that was displayed as a mnemonic. There was like several words that were together in the top. That's what you can use to restore an account. And then here is the one to recover the account. So we're going to take that mnemonic phrase, and then we're going to get the recovered account from that. And then coming down again to the bottom here, we have submit the transaction. And we're going to put that information into the note field, get passed into the call, and then you have the signing, right? So the signing involves what's called sending a raw transaction. So this is the command that sends it out to the network. This is the call that signs it. So you're not done after you sign it. Now you got to broadcast it. And the broadcasting, this is where we'll take a look at double spending, if you have enough funds and all that kind of stuff. And that is, kind of the walkthrough of the code. All righty. So the next one I want to show you is our developer portal. And let's take a look. Like, here's that getting started one I talked about. And Many features in here. You got also you've got ability to using VS Code, with all these different languages, and a lot of great resources on this. But other tutorials that might be in here, the thing I want to point out to is let's go like say create an asset right here. So on the bottom, what you'll see is an area where there's a link to the code, and these will have that available to you in the documentation. For example, under features, you can explore features. You can go to assets, and then you can see down here each one of these assets. If you go right down to the bottom there, you can see all the sample code in here, and then as well as the folder here that contains all of the assets, and you can click on it, and there's a V1 and V2 folder, and this has, again, all the code that you would need for something like that. One other quick demo then, I want to go ahead and get the as promised, the Visual Studio app up here. And there it is. And we're going to run this in the iPad emulator. And there it comes up. And again, this is all done in C#. And once this loads up, you'll see you have a lot of flexibility in using this app. One is to go ahead and use and set up your node and network. You got a few different options here. You can go to testnet or betanet. You can enter your own node. I've got it going to the the sandbox, right? So that's my IP address there. You can go to PureStake or Hackathon. They have both of these. We have like a Hackathon instance that can be used. If you go to a Hackathon, we provide that, and that's what I'm using in this app. And so what you'll want to do is replace that, with your own node in the code. And then you get to this one, accounts and transactions. So I'm going to go say get block information. This will go ahead and retrieve information. You see it all displayed like we saw in the JavaScript application. I'm going to generate account. So here's the account number. There's the mnemonic. Also, it's going to need some funds. So let's go out to the dispenser, and it's going to the testnet dispenser. We also have a dispenser for betanet. Oh, this is a little tougher. Mountains. I think I got them all. Good. And let's go ahead and paste that in. Dispense funds, go back over to the app. And now we got that. So now I can do a transfer from account 1 to account 2. So account 2 is, I already created that previously in account 1 before this demo went, and there you can see it. Now you've got the 1,107, so it's not even anymore. We did actually transfer some money. And then also I can create a multi-sig address and then send a transaction to that as well. Also, then I've got the ability to do Algorand standard assets. So here we're going to go ahead and create an asset. This gets created, and all this, again, all this code is in here. This code is actually on the DevRel-Hackathon Algorand-DevRel GitHub repository. And I'll actually put that link into the chat window because I didn't put that on the slide. There it is. It's in this repository right there. Oh, yep, there you go. And so now this app, back to the, here it is. So now I've done and created the actual asset. Now I can configure this. I could say, okay, who is going to do the freezing, the managing, and so forth. And there you can see that was done successfully. So here I changed the manager role to a different account. You can see right there. And then finally, I'm going to opt in to receive in account 3, this particular asset that I created. And then once that's done, I can do a transfer now from account 1 to account 2. You can see account 3 has a balance of 0. And now once I do that, and again, this is a balance in terms of the asset that I've created. And then so you can see now I've got 10 in there I just transferred over. I can also freeze that account, so we cannot do any transactions. And the manager also has revoke rights where they can claw back that amount. So now you can see it's set to true, it's frozen, but the manager still can revoke it and they can claw it back, but just account 3 can't do any transactions on its own. And then finally, if you do own all the assets, you have the ability to destroy it if you like, and that's really the full functionality of our chain. So I'm going to wrap up here. I see it's 3:45 on the dot. Again, you will want to check out that there was one example I think I said I was going to show you, which was the Algo. Yeah, there it was, Algo.io. Again, it's kind of a really cool tool set, and they have the same thing on asset manage. So what I did here in the code, you can actually do visually. So they're giving you a mnemonic to get started with. You hit get started, and then you can go ahead and just create an asset, just fill in the information, and boom, you got your asset set. Also, this is a great tool here on this site to look at some of the other tools that they had for the teal editor and that kind of thing. All right, so let me bring back the deck here, and we will close it up here today and get you off to that keynote. All righty. Oh yeah, this is really great. Chad did this interview with me about a month ago. I call it Russ Unplugged, and make sure you tune into this. This is really a cool video. In fact, I'll copy this off and paste that in as well. You can get it from there. And it's a good, discussion that we have on this. We talk about Code PaLOusa, the networking capabilities in it, the blockchain, and also, getting started with developer evangelism. If any of you would like to look into that as a career. And so, useful resources. Once again, definitely check out the developer portal, the forums, GitHub, Discord. We have our own channel there now, and PowerPoint download in case you missed it and joined late. That's the link for it as well, and I could repost that into the Slack. And folks, that's all I got. If you got any questions, put them in the chat window. I'll hang out here for a little bit until you go, but hopefully you enjoyed that session. I'll put that link right in here. There it is. All right, you're welcome, Wayne. Evan, yeah. You're welcome, Evan. Yeah. Okay. Didn't realize I was posting it over there. Okay. All right, cool. I guess it's a wrap. We'll see y'all in the closing ceremony here today. Thanks.